Okay, so the point here is to show you that a logistic regression is not that different from the idea of a regression. If we click on regression, we're going to go to logistic instead of linear because our outcome, whether or not we get into med school, or acceptance into med school, is a yes-no variable, which means a linear regression probably wouldn't do a great job at predicting this. And we're just going to use initially MCAT as our only predictor for this question. So right away we have our model. For part A, you need to write the equation. So you would have two possible equations here. One would be that the logit of our predicted acceptance rate into med school equals negative 8.712 plus 0.246 times the MCAT score. So that one's really simple on the right side of the equation. It's very similar to what we did in linear regression. The problem is the left side of the equation isn't predicted acceptance rate into med school, it's the logit of that. The other equation then would give us the acceptance rate into med school on the left side, but then we would need to raise that expression that we had on the right side according to the formula on page 420. So again, you could just plug it in. This would be your beta 0, and this would be your beta 1, and the formula is right there. And that gives you a really nice, simple left side of the equation because it's the acceptance into med school. It's the thing you're directly going after, even if it's a little trickier on the right side. The next thing we could do is compute an estimated odds ratio. And this would just be E, which is 2.7182, so on. It's called Euler's number, raised to this power. Or one way we could get that pretty quickly would be to look at the statistics, click on odds ratio, and we'd see that that is 1.279. Okay, for parts C and D, we could plug them into the equation and solve them algebraically. I want to show you what you could do here to get a real rough estimate, and then we could also look at how we do that algebraically. If we click on our plots, and inferential plots display conditional estimates, this will give us a nice visual of the relationship between the MCAT score and the acceptance into med school. Notice that this bottoms out at 0 and ceilings out at 1.0 because you can't have more than a 100% chance or more than a probability of 1. Notice also that based on our data points, our best fitting line here is this black line, and then this gray area is our 95% confidence because we just have a sample here. We don't have the entire population. You might notice that the confidence interval, there's a lot more room for it to be above our prediction here at the lower MCAT scores, and a lot more room to be, above our prediction here, and more room to be below our prediction here, just because think about what that would mean if our confidence interval was equidistant from the line. We'd have potential points up here that are above a probability of 1, or down here that are below 0. So that confidence interval isn't quite as symmetric as we saw before. So let's take a look at parts C and D. C, we have an MCAT score of 40, and we want to know the probability of acceptance. Well, if we follow that 40 up right here, we can see that we are somewhere in the upper 70s in terms of acceptance. 76% is what we would get once we plug 40 into either of the regression equations, logistic regression equations we got in part A. And then, the second question was saying, what MCAT score would you need to get a 50-50 chance of acceptance? So that means we would start here at a 50%. We'd be going until we hit the line, and then we would come down. So it looks like a little bit above 35 as a rough estimate. And again, we can use algebra to calculate that more precisely based on our model.